Hello, I'm Frank Lamb with the Automation Academy, and this is a Mastering the Machine webinar for October 8th, 2021. Our topic today was microcontrollers, systems on a chip, single board controllers, and that sort of thing. We had several guests on here today talking about the things they're working on. Jerry Wasinger, Phil Scruggs, Mike O'Day, John Sullivan, and more. And I hope you enjoy it. This is about the 40th Mastering the Machine video that I've had since late last year. Yes. So I think people know me normally as a PLC guy. I do a lot of PLC stuff on LinkedIn and other places, but today's topic is a little bit different. We're going to be talking about microcontrollers, single board computers, systems on a chip, and some people refer to them generically as Raspberry Pi and Arduino and things like that, but there are of course a lot of other brands, and we'll be talking about all those and a little bit about their application in industrial settings, which is normally where I do most of my work in industry. What is Mastering the Machine? I always do a little description here. Mastering the Machine, the name comes from a document that I put out a long time ago, and people download it from these two sites. And then it grew into something called the Automation Academy. The Automation Academy is an online membership site. And among other things, I do these webinars on the Automation Academy. What is the Automation Academy? I do training videos for Allen Bradley, Siemens, and Omron PLCs. There's some job and aptitude assistance on their systems integration topics, that sort of thing. There is a library of downloadable files, lots of training and technical documents, mostly very industrial, but I have lately put a lot of things on Raspberry Pi. I noticed Jerry just signed in here. Hello. And Jerry, some of his documents are in there. I put some things on some of his products. He'll be talking a little bit later also, I imagine. There is a community on there with interest groups, right? So it's kind of like another little tiny LinkedIn. People join different interest groups on there. And one of the interest groups I recently created was microcontrollers, which is the topic for today. And then, of course, I hold regular events. Every 2 weeks, I have Mastering the Machine webinars. So the Automation Academy is about 9 months old at this point, and I've had a webinar about every 2 weeks. So that's enough of the advertisement part. And so today's topic is microcontrollers and their uses. And in particular, there have been some very good discussions on LinkedIn about the aptitude of things like Raspberry Pis and Arduinos and ESP32 and those sort of things, BeagleBone, for industrial applications. And so some of the people that are on here, I'm going to take a look and see if anybody else, yeah, we got about 8 people on here. So people like Mike O'Day, he may be sharing a little bit. John Sullivan is here, and John's done a lot of work in microcontrollers. And I think Philip Scruggs is probably here. Let me take a look. It looks like we got about 9 different people, and I can't tell who's on here, but some people like Philip also have already appeared on this webinar and talked about some of the things they do with Raspberry Pis and cameras and things like that. So anyway, that's enough about me. As I mentioned, I'm known more as a PLC guy, but today we're talking about microcontrollers, which I am not an expert on, right? So I'm going to rely on a lot of other people that are on this webinar to chime in and talk about microcontrollers. Microcontrollers, my little spiel here, single board computers, Raspberry Pi. I did some research on some other ones, Google Coral, Intel Nuke, BeagleBoard has a computer, Odroid, Latte Panda, and the Udo Bolt. So I have no experience with any of those other than the Raspberry Pi. I have about 5 Raspberry Pis, and I do various different things with them, including a project or 2 with some outside people using the Raspberry Pi. So I'm kind of learning it as I go. Mostly been on the hardware side so far, done a little bit of programming. microcontrollers, systems on a chip, Arduino. I bought a whole bunch of Arduino stuff several years ago, cleaned out all the Radio Shacks in the area, bought all their little toys and lots of little sensors and things and played with it a little bit. Other brands, and I think somebody on here is going to be getting on and talking about ESP32, which is made by a Chinese company, and that seems to be pretty popular. And BeagleBone's another one that I've heard of. Then when I did research, I found Intel, right? They have something called a Quark, and then NVIDIA, which I always thought was, I guess, TV screens. They have something called a Jetson. And then Adafruit even has its own little product, which is kind of interesting. And then there are some industrial versions, and Raspberry Pi also has industrial versions of things, as I guess ESP32 does. This one in particular, Coonbus, a lot of people talking about that on LinkedIn, the Revolution Pi, and that's a picture of it. It looks like a little PLC here. This is not a particularly inexpensive device. I think you're up in the range of some PLCs there. So that's some of the products. And then we're going to be talking today a little bit about the pros and cons, and I'm going to let some other people talk more about some of these products and their possible uses. Pros, much less expensive. And I actually have a little list down at the bottom. I see Jerry here, and I have a list of some of his products that I've put together in a little package. I don't know if you can see me on my camera here. I can't see myself, but this is a little box that I put together with a Raspberry Pi in it. You can see the Pi here. And this is one of Jerry Wasinger of Pi Plates products, right? He has these little boards and things. This is called a case plate, and you can put it together and it stacks things up. And then there's a power module in here, and there is a relay module in here, and there is a digital acquisition plate, a DAC plate in here. So it takes some analog IO. And just for example, something like that, these are some of the costs. So you're really low cost here, right? I got about $263 in a little stack like this. That would do 8 digital inputs, 15 digital outputs, 7 relay outputs, 8 analog inputs, and 6 analog outputs. So that's like a pretty big PLC, right? That's a several $1,000 PLC, probably, even the cheap ones, Automation Direct. So part of the discussion today is, is it worth it? This stuff is 5 volts, right? It's pretty low voltage stuff. Can you use it in industrial applications? Well, a lot of people don't know. PLCs are, really 5 volts at their heart, right? The boards inside of them, the processors, and a lot of the cards are running on 5 volts, but they shield things. They make it industrial. So you do have to make things rugged. You have to use things like some of Jerry's products and put them in a package and isolate them from things like 120 volts, or worse yet, 480, right? We have 480 in industry quite a bit. But again, much less expensive, very flexible, computer-based, and it's evolving. Some of the cons, and these have been mentioned on LinkedIn, not very rugged, right? If you drop it, it might break. Or granted, the power is 5 volts. So if you take a power hit and you get something like 24 volts or 120 volts into it, it's going to burn it up. The card is a problem, right? The SD-RAM card, it takes X number of writes, and eventually you can wear them out. Now, I've seen people that have been using these 24 hours a day, and they run for a year on the same card. I've seen other people complain that, hey, these Raspberry Pis are destroying my SD-RAM cards, and I'm going to sue Raspberry Pi. I'm in England, and you're destroying my products, my equipment, right? I'm going through RAM cards like crazy. I don't know. I can't vouch for that. I do have one in the other room here that's been on for 3 weeks now, and it's running fine, and the card's not getting destroyed. I don't write to the card very often. Another con, non-standard IO, right? You're not doing a lot of 4 to 20 milliamp, 0 to 10 volt. There is some of that. Some of the cards here in the Pi plates will handle 0 to 10 volts, things like that. And then non-standard programming, and I'm going to address that a little bit. Not sure if Mike O'Day is on here, but I've talked to him a lot lately, and he's been using Node-RED, right? And Node-RED is pretty standard programming. There are a lot of functions that have been created, including by Jerry, who's on this, and Jerry has created some nodes, right? Some functions that address some of his products. So anyway, I'm going to open it up now. I see Mike on here, and I saw Jerry on here. I know John Sullivan's on here. I think real quick, I'm going to get John on first, because John has a product that I think he wants to show that is not a Raspberry Pi. I think it's an ESP32, and we'll give John a few minutes to explain that if he's on here. John Sullivan, are you there?
Yeah, Frank, I'm here.
Okay, great. Yeah, let us know what you're doing.
Yeah, so when the topic went off to Raspberry Pis, I don't have an ESP32, but the topic of Pis, the work that I do, we've been looking at various. I work for a company that does edge analytics and AI and machine learning and stuff like that, and we can take cloud learning models and shrink them down and make them run quicker and faster and less expensively near the asset where they usually belong. So we've been looking at some different compute options. Sometimes the edge doesn't always mean a small device like the ones we're talking about today. Sometimes it could be a server that just happens to be near equipment. Really depends on the compute that you need. So that's an important consideration, just like we would for PLCs. But one of the things I ran across was that the Raspberry Pi Foundation had noticed that like 50%, I've heard it said, of all Raspberry Pis are actually being used in industrial settings. So they began to open that up to a couple of manufacturers to go ahead and take their technology, what they call their compute module. So it's basically a board with the Raspberry Pi 4 chip on it that they can build a system around. So one of the companies I happened to be looking at and talking with was a company called OnLogic. And they have a whole line of things from like small gateway devices to server type things. And they were one of the companies tapped to make these industrial Raspberry Pis. And so that's what they're working on. You can find a page on their site about it. It's still in prototype, getting ready to come out probably in the next quarter. But what they're doing there is answering those questions of, hey, if I take like my little home one I can buy off Amazon, but I can't go put it, in minus 20-degree weather, or plus 60, Celsius, it's not going to survive. So now with the compute module being built that way, they can actually build the rest of the framework system around it with those components that are rated for those kind of temperature ranges, for example, or other environments. So they have a couple of other, I'll call them fanless type devices like we would expect from some of these things. And this is just another one of those, and that'll be another one of those in that line. But it will be Raspberry Pi 4 powered. And for the price point, we put them up against some other ones. Usually, like you find Intel Atoms in that space for processor power. Sometimes you go up to Celeron or whatever. But if you're trying to really hit the low price point, you're going to be looking at a Pi or an Atom for your processor usually. The other factors I tend to see people looking for is like, well, do I need it to be, dust proof, IP67, for example? Well, every board that has a hole in it's never going to pass that. So you're going to stick them in an enclosure, but now that's going to raise your heat. So you have to look at that. Another company's products that I've actually used when I was in the paper converting plant was from a company called CompuLab. And I think they're sold out of the US through a company called FitPC, but you can get them through CompuLab as well. It's a company based out of Israel. They have some amazing tech. The stuff that they can shrink down into a box this size is like here, it's still the size of the Pi, but you're actually got like an Intel i5 in there or something. Changeable face plates depending on what you want to do with it. Do you need a bunch of antennas? Do you want a bunch of NIC ports? Kind of build it what you want. Also can be fanless. I've seen them run I think they have an i7 or an i9 tower. They've designed the cooling so it's like a chimney effect that it actually is still all fanless. It's all, the way that they've designed it to take the heat away from things. So some pretty impressive tech is out there. One of the interesting things I ran into was you really have to check every little thing, because one of the companies was like, we have a computer, it'll meet your temperature spec. I think we were looking for like -20 to +60 Celsius for some reason. Maybe it needs to be outdoors up north or whatever. And they were like, the device is rated for that, but the power supply that comes with it is not rated for that temperature range. So you got to spend an extra chunk of change to buy this other power supply. And I never would have thought of that, because yes, I'm going to stick it all in a box, put it in an enclosure somewhere, outside or whatever. So a lot of things to check there, but they're starting to come out. So that's some interesting stuff there.
Absolutely. So one of the plugs I'll give this little product here, there is a fan on this. I think the module you're talking about, are you talking about the Compute 4, the Raspberry Pi Compute 4? Yeah. And I think possibly, for instance, Coon Bus has built the Compute. I don't know if that's a Compute 4 base. But one of the things I saw that another thing they addressed was that they had an eMMC, which I think that kind of gets around destroying the cards, which was, that's one of the big complaints too. But well, that's awesome, man. So what's the thing you were holding in your hand there? That's just
this just happened to be one of the Pis that I don't have currently hooked up at my desk, which is, it's amazing the stuff you can do with these things. I've got a Pi, so you can't probably see it, but I've got some vibration sensors from IFM sitting here on a metal wall rack, just leaning against the desk with the power supply, putting out 24 volts. But I've got a Pi here that I'm running OpenVPN on, that I have coworkers from across the world. Literally there's a coworker in Germany who remotes in securely through OpenVPN, and he connects and reads data from these vibration sensors back to Germany as we're building stuff. And then I've got a couple other here running our Edge software, and this is an Intel Atom device running Windows 10 that I'm using for some of our software. So it's amazing what you can do with these devices that are relatively inexpensive compared to, a $2,000 plus chunk of equipment. So, but I'm very interested to hear about all the other things and folks that you have on here to learn some more as well. So
sure. Mike O'Day, are you there?
Yeah, I'm here.
Okay, Mike. I've talked to Mike a lot about a particular project, and I don't know how much Mike can share. But Mike is a user of some of Jerry Wasinger's products, the Pi plates, and he's working on a project that's pretty interesting. And he's the one who actually introduced me to Jerry and showed me some of these things, and I got real excited about it because I build little boxes, some of the things that you see behind me here, and I put PLCs in them, and I do training, right? And I put they're pretty open. A lot of times I have mesh sides and I can tie wrap cables to it and things like that. So great for training. And all of a sudden I was like, well, now I have a use for these Raspberry Pis. I have like 5 of them sitting around here that I've played around with, but suddenly I can, I have a kind of a purpose, so I can build them into these boxes. And I know Mike is working on a project where he's got something mounted on the DIN plates, which I don't have DIN plates yet. This is a case plate, and it's just plastic. But the DIN plates allows you to hang it on DIN rail, and once again has a fan and a separate power supply and all that kind of stuff. So it kind of isolates the Pi from some of the environmental things. But Mike, anything you want to say about your project?
Yeah, I mean, I don't want to go into too much detail about it, but for just Keter itself, we're trash and recycling. So trying to make sure that for the customers we service, we provide effective and efficient service, and helping them manage something that's not always top of mind unless it doesn't work, which is trash and recycling. As long as it gets picked up, everybody's pretty happy. But from managing a large property, it can be if not efficiently managed, it can be a cost driver versus cost managed service. So we provide that to our customers, and we have probably over 500 different sites we manage across the United States, and a bunch of different containers that we put to collect the trash or the recycling material. And so it's important for us in being able to have effective and efficient operations to have as much data as possible, right? That's nothing different to anyone else managing a company these days. But uniquely for us, or maybe not uniquely, the edge case is kind of what drives a lot of our constraints around what we can do. The edge case being that, largely these are containers that are out in a, middle of a property somewhere. Could be Minneapolis, Minnesota, could be Phoenix, so the temperature extremes can be pretty extreme. And then, serviceability becomes an issue because, it's a deployed device somewhere. Collecting the data off it often isn't as straightforward as you might find, because it's in a lot of cases just covered by a cellular network. And then once cellular enters the picture, that drives cost on the design that you're putting out there, both from the equipment that you might have to deploy, as well as the data charges that you might have to deal with. So in the past, we relied a lot on, kind of PLC based devices. And so we were trying to kind of take another look at that design. And a lot of the issue with PLC we were running into was it could be very chatty to have those communications to a PLC device. So, looking at something that was more compute based so that we could do some of the processing at the site without a lot of the chatter back and forth over the cellular network was important. So we've looked at some of the emerging devices, and they're all kind of emerging, and they do a fine job from a wired perspective, where they do a fine job. A lot of them provide like a dongle based USB to connect up to a Wi-Fi network, et cetera, but sort of haven't still crossed into like, how do you deploy as small a footprint as possible over a cellular connection from an edge perspective. So we've had some conversations with some of the manufacturers that were on the other slide about, where they can go with that. But, we've got a timing that we're working against because of I don't know who's going to win and who's going to blink first around 3G. Whether that goes lights out in February or not, remains to be seen. The carriers are pretty insistent it's going to go lights out starting in February. Hard to predict if we'll be on a particular day in February or over several months, but that has a lot of impact to a lot of folks. So we'll see what happens ultimately. But that's driving a lot of our design around deployment. So, not wanting to necessarily put a device out that has the cost of a PLC chatty over a network over the cellular side, and then not being able to kind of take advantage of some of these products because they're emerging on the cellular side. We fell back to kind of a Pi, not wanting to sit there and try and figure out how to wire up GPIO pins to something concoct stuck in a box somewhere out in the parking lot. Luckily, I came across Jerry and his products. So, we've got, kind of your Raspberry Pi hooked up to, we've got a power plate, we've got a data acquisition plate, and then we've got the DIN plate, so that allows us to DIN rail mount it. And then the other thing is I came across a Japanese startup, Soracom, and they provide this USB mounted cellular modem. So for those that have had to deploy the antenna based industrial modems, those are great for the use case you have, but in our particular use case, we're trying to shrink down the footprint. So this was interesting to us. And Soracom provides back software as a service connectivity to AWS, Google Cloud, and Azure, Microsoft Azure. So you can basically use their modem over their back. So it's encrypted over the carrier's network, encrypted over their software as a service out to their funnel software as a service, and then out to, encrypted to AWS. We've got a couple of use cases where we've gone through Kinesis data fire hose to S3 buckets, so you can store it there if you want. Azure, out to Azure to IoT hubs, and then not messing too much with the Google Cloud side, but definitely can do AWS and Azure. And then not going through the Soracom network, you can probably save some money. So we've got some VPN, VPC work we're looking at using different cellular providers that reduce some of the cellular cost, and that goes out to MQTT using Sparkplug out to HiveMQ cloud. So we can do kind of MQTT messaging for those deployed devices and collecting information at HiveMQ. So that's kind of like the 30,000 foot level of what we've done.
Very cool.
Now, I don't know like we're getting close to field trials. So the question will be, like you kind of said, Frank, and others have said, like, okay, you put it in a box and it's whirring away, does it fail in a week? Does it fail in a month? Does it fail in a quarter, a year? That'll be kind of what we're interested in kind of determining. And at some point, maybe some of the manufacturers on the slide, come out with their more hardened versions, and then we can swap it out. The benefit being that if we've done all the prototyping in Node-RED, those flows can be ported over to those devices, because most, if not all, those devices support Node-RED.
Exactly. So some of these products, these are hardened products. I do notice that the Coon Bus device, they've addressed the memory issue, and they've addressed the 5 volt issue. A lot of this stuff's 24 volt, and it's got a memory card and things like that. But the cost is getting up there. I noticed the controller itself, I think, was $600 or $700. I've also looked into, I don't know if you can see behind me, but there's a PLC Next down here, and I've got a demo from my local vendor, and I'm going to play with that a little bit. It has MQTT, and it allows you to do things in Node-RED, but the controller itself, I want to say, is $800, and that's not even any IO. So by the time you get into that, you're still up around $1,500 or $2,000. I believe the Groove, I think the controller itself is somewhere around $700 or something like that. And by the time you get down to these kind of prices here, right, you're at $200 and some. Now, I know from my background, Phil Scruggs, are you here?
Yes, I'm here.
So Phil went down to Miami with me. We had a pretty fun little time. Wow, you look different, Phil. You got.
I know. I look
no beard,
a little bit different.
So Phil went down to Miami with me, and he spent a couple days in a plant called American Beverage Depot, which I've had some presentations here from there. And as a matter of fact, Phil and I did a kind of a webinar. I think I was there, and he was maybe up at his place. He was my guest. He was my first guest on here, and then he was one of the later guests also. He's a member of the Automation Academy, and sometimes helps me, gives me some advice. But he went down there and saw what I would consider a somewhat nasty plant. It could be pretty dirty. It's definitely hot. They have lightning storms down there, all kinds of issues. And we talked about some of the data acquisition challenges that I've had. So one in particular was we have PLCs down there that are, many $1,000 PLCs, big control logic systems and Siemens 400s and things like that. And our challenge has been, how are we going to get data from a lot of these devices around the plant, right? Just simple things, photo eyes. I just want to count boxes and things like that. And we talked about putting together some very simple devices that you would literally unplug a photo eye and put a device in between the photo eye and the cable, let the 24 volts from the cable power the device, and it would be a little remote thing that would transmit to a central location, and maybe use something like MQTT to go and pull those devices, something like a Pi. In that case, let's say we use something like this list that I have on the screen here, and I put a Pi, and it's a DIN rail mount Pi. I have a lot of options here. I can put it in a box with air conditioning if I want it, right? And it's not even that expensive. They have like these little Vortec coolers that you can hook up to compressed air, and they'll actually cool off your cabinet if you have compressed air locally. That's a neat little tool. Of course, fans, things like that, really no problem. Addressing things like the ever-failing SD-RAM card. If that fails, is it a big deal that I lose my signal that's already going to a PLC for control, but I lose the signal from that particular photo eye or from some of the sensors on a particular node? Not a big deal, and I probably know pretty immediately that, hey, that node's gone out. And at some point, the maintenance guy goes around and he simply slides another $7 or $8 SD-RAM card into the Pi. It's got the entire operating system on it. Would the Pi itself fail? There are lightning controllers, lightning strikes and things like that down there, but they've lost device net, they've lost processors, and some of these they've lost drives, $4,000 drives. all kinds of things down there. So things go wrong down there anyway, and it's very expensive to replace. You got to have a spare, got to have a control logics processor or something like that. So even if you threw this whole thing away, you know, you lost all the plates and everything else, you're out $260, or you're out an $8 RAM card, which is the most likely thing to go, or you're out maybe a little 5-volt power supply or something like that. Now, it remains to be seen, is this thing hardy enough to, you know, withstand lightning strikes in Miami? Well, I'm going to find out, because I'm going to be putting a couple of these down there and testing some things out. But so another person that we had on here, Phil, showed some really great stuff. If anybody gets a chance, on my YouTube channel, I have a automatic eye here. I have one of the webinars that we did, and Phil showed some of the things he's just doing at home. That he did some. It almost looked like facial recognition, but it was a temperature checker with an infrared camera that would tell whether, you know, theoretically somebody has a fever, right? Which we all know what that is.
Yeah, no, that's a different one. But I've got a kind of fun project that I can show today. It mostly in relation to the initial part of the conversation where you were kind of describing how sometimes it's kind of hard to come into a plant and do an OEE calculation or do some of the key performance things that you as a consultant are going to come in and kind of suggest, because some of that equipment does require regulatory approval, or you do have to hire a specific expert from that system to come in and attach a new photo eye or provide just a simple count. For instance, how many boxes are going by the machine? And so how can you as a engineer go into a facility and get that information without having to spend months and months getting the required information? Oftentimes it's simple as, hey, can I put this, in certain facilities, can I just stick this little box on this machine? And most of the time, or sometimes, people say yes. And so a lot of times it doesn't even take a Raspberry Pi to do that, which is basically, you know, a single board computer. Sometimes it can be a very, very low cost chip. This is the ESP32. It's tiny, they're cheap. The project I'm going to demo in about a second or two is ESP8266, which is even older version of ESP32. You can get these little microcontrollers for 50 cents each. You know, they're almost throwaway cost. And so what I kind of have behind me, I don't know if we can really see it. Let's see.
I see Sean Terrell chiming in. Would recommend a D1 Mini for that. For sure. Okay.
So this is just a garage door opener detector, right? So when something is blocking the line of sight, you know, it breaks the signal and you get a count. And so I wanted to get off-the-shelf hardware. We had discussed photo eyes, but a Banner photo eye was $60 at least just for a industrial grade photo eye. So I was kind of thinking, hey, why don't we go to the off-the-shelf components, consumer grade? These are in garages and gates across the country. They manufacture 1 million of these a year. And this is $60. It's battery powered. The battery should last about a year inside of here. And what it's set up to do is inside, I've just gone in and where it has a relay, a simple relay. It's attached to the ESP8266. It's just a small microcontroller on Wi-Fi. And it's doing MQTT pub sub. So it's providing an MQTT subscription with updated values. And so I guess maybe I'll request permission to share the screen, but each time my hand passes, or actually I just break the line of sight by moving it up or down, it's creating a count. And so I can go ahead and show that really quick if you enable screen share.
Go ahead and do that. I'm interested.
One of the things with a lot of the demos that I've kind of observed is people talk about all the amazing things it does, but they don't really see it in action. So a lot of times it's important to see, okay, here's a cool product. It's just powered by a 12-volt battery inside of it, attached to an ESP32 or 8266. But what does the data stream coming out look like? Let's see. All right, are we screen sharing?
Yeah, I see your screen.
Great.
Yeah.
Great. So right now we have something called an ESP8266 count. That's the topic. And inside of here, we have some values. And so each time I kind of move this up or down or break it with my head, because it's kind of hard to show, but you can imagine this being placed on a manufacturing line or even a door to count how many people are coming into or out of a facility. And so the total cost of this is going to be $66, $65 for this and $1 for the microcontroller. And so that's what's kind of important, is just kind of showing what you can do with it. I'm using the ESP8266. That's just Wi-Fi and Bluetooth. So you would have to have Wi-Fi access to the plant or facility. There are devices such as this. This is called a particle boron. It's got a little modem on it. It's really popular. The plans are free, up to 100 devices, I think. And I was packaging this in here and shorted out one of the terminals. So we don't have a cellular based product right now. We just have the Wi-Fi one for today's demo.
Well, this is exactly what we were talking about down there. And one of my frustrations, for those of you who are in the industrial world, I'll give you an example. I was in Miami and I had already told the maintenance manager, hey, I need some point IO modules stuck out in here so that I can wire, you know, photo eyes and things like that in them, pick up some of these signals from the PLCs. And he said, sure, you know, we'll wire it in. So 2 days later, it's wired in. I go out there and try to connect to it. It's a version 6. And all the PLCs that are in there, I can't flash it back to 5 or 3 or anything. The PLCs that need to access it need version 3 through 5. So my next step is I tell the maintenance guy, I said, you're going to have to, you know, I can't flash this. You're going to have to find another point IO module. 3 days later, he says, yeah, I've got one on the way. You know, I'll have somebody go out and replace it. And I said, well, I'm leaving tomorrow. So the next time I'm down here, and I'm the only person who can really add it, right, to do all the configuration. So it's been literally probably a year since we've been trying to pick up some of these points. And for various reasons, we can't, you know, just dig straight into the PLC. I've had these conversations with some other people that either the company won't let you, or in my case, they're like, some of them are old GE PLCs that when you start hammering the communication port, this was Mike O'Day's point, that if you're hammering the communication port, it actually has a watchdog timer inside of it that says, hey, your encoder is not updating fast enough, shut down, right? Because you're trying to communicate, you're using the communication port instead of, you know, it's actually slowing the program down. So that's the kind of thing I've been facing there. And Phil's solution would have worked, because in many cases, that's all I need. I want to know how many boxes went down this line. And I actually want to know a year ago, right? I want to put 5 of the things he just showed you on the line, and I just need box counts for now, right? We can do OEE on the whole line if we can just pick up a few box counts, cases, boxes, things like that. So I think these solutions are coming. I think things are getting less expensive, and the $10,000, you know, ControlLogix processor is not always necessary. Obviously, I'm going to go back real quick here. Well, actually, Jerry's on here too. I would love Jerry to show us some of his stuff. Do you have anything you can share a screen with, Jerry, or do you want to just tell us a little bit?
I'm just going to shove things up to my camera so you can see them.
Okay.
That work? All right. So when I first started the company, pipe rates, I was more focused on more the Adafruit kind of area, which was hobbyists and then tinkerers and experimenters and things like that. Slowly, I've told Mike this, I've slowly been pivoting the company towards the industrial side, primarily because that's really my focus of interest, and I think there's a better market there. So to that end, probably within the next quarter, I'm going to be releasing 4 new products focused purely on the industrial side. The first one is going to be this one, which is the 4 to 20 milliamp input, 8 channels, each one isolated from the other, 16 bits. That's the first one. Second one is going to be trying to see what I'm trying to, that's going to be 8 digital inputs, good up to 30 volts. Can be with these jumpers. I'm going to show these jumpers. I stabbed myself on those the other day. With those jumpers, you can select one of 3 different input types. I don't know how familiar you guys are with that. I think there's a type 2, type 3, and good old-fashioned digital. Third product, and this is sort of a prototype. This is going to be an industrial-grade relay plate. It's going to handle 5 amps, and it's going to be good up to 250 volts. Sorry, I can't do 480 yet. I could probably put 2 relays on there if you want 480 volts. The dim plate, which I'm sure you're looking forward to, Frank. And the last thing that, and then I've also got a 24-bit ADD converter, 8 channels coming along. Now, I don't know how important ADD conversions are in the industrial space, but this is probably going to be more towards the scientific area, but that's also targeted for this area. The dim plate, like I said, and there's one other plate that I realized is necessary, and even after having this conversation today, and that's going to be a power plate that accepts 24 volts. And then converts that 24 volts to the 5 volts that the Raspberry Pi needs. And it'll probably come back out and do 24 volts on pins on the front. So you can power up other peripherals with it. You're still going to need a Meanwell power supply or something like that. But at least this will give you the means of distributing the power. So that's what's coming.
Yeah, the other thing is we have 24 volts everywhere in plants. So we're just half the time tapping off of what's already there.
Right, right. And the first time somebody said, well, we need to have 24 volts inputs, and I went, are you crazy? I did take a couple of notes while you guys were talking. You're really worried about your SD card getting trashed if you write to it a whole lot. One of the ways around that is to write to an external thumb drive. Boot off your SD card, but write to an external thumb drive or an external, flash, SD card that's plugged into the USB port. You can write to that thing all day. You don't need to worry about losing your SD card because it's not going to get a whole lot of traffic. Couple of companies that I sell a lot of product to that's in the industrial space is Aerospace, and they're in Torrance, California. They make rivets for airplanes, and they put some of Raspberry Pi on top of all of their grinding machines on a very nasty floor. The other company I sell a lot of product to is Function of Beauty up in Pennsylvania, and they make custom shampoo. So they've got all these little valves I think they're using, and they use my relay plate for, and they just turn those valves off and on. So when I get an order from them, I'm a happy man because they buy hundreds at a time. So anyway.
Yeah, I'm convinced, like I said, when you dig into things, you take them apart, you take PLCs apart, it's all at heart 5 volts anyway.
Yes, because all the electronics runs off of that. And Phil, I want to address your comment that you just made. The compute module goes to a breakout board, and the breakout board has all the I/O you need if they bring it out. So depending on the breakout board you buy, you can get what you need. And I was telling Mike this, the only Raspberry Pi that you can really get in quantity and can count on getting is the compute module. Getting the Pi 4 right now, my local Micro Center is completely sold out. So that might be on the drawing board in my near future, is to come up with a breakout board for a compute board. But for now, that's going to be a little bit of an investment in time and money.
Yeah, I've noticed that everybody's sold out, including, so I'm a little bit responsible for your Micro Center being out. I went in there and bought several on my way up. That's in Marietta, right? Marietta, Georgia.
Well, the one that's real close to me is in Duluth.
In Duluth, there's another one.
Yeah.
Okay.
But Marietta, yes, Marietta was the first one. And then they opened up one here, and I've spent a lot of money there.
Yeah, I stopped in Baltimore and in Washington, and I ended up Washington D.C., which has 2 micro centers, and I ended up buying another, I think 3. So I've got a total of 5 right now, like I said. And then of course they have these little picos and things like that, which I don't know. I haven't quite figured out how you get to the breakout point. You have to solder things, and
Well, a pico is just basically a microprocessor.
yeah.
So it's a nice little device, but it's more in the Arduino space. It kind of bridges. It's on the fence between Arduino and Raspberry Pi, but it definitely leans more towards Arduino. But it's a cool little device. It has a lot of it's an ARM processor. It's a very nice one. So that's all I got. Anybody have any questions about pie plates and where we're going and where we came from?
No, glad to hear about it, though. Gonna have to look you up.
Yeah.
I actually do have one question.
Yep. Question?
Oh, go ahead.
No, go ahead, Jeff.
One of the things I was going to ask about on some of the controllers we've had, they use what's called capacitive decoupling, because what they'll do is they'll have an IC that has 8 inputs on it. And the only way that you can keep one input from being affected by the other is through capacitive decoupling. So they've got little non-polarized capacitors on there, so that say you've got a binary input that's switching, that's right next to something else reading a temperature. The temperature doesn't start floating because the other input is going on and off, pulling the voltage up and down. That's one of the only things I haven't really seen much of on the little third-party, add-on Pi hardware. I haven't seen any decoupling capacitors on them, and I'm wondering, in an industrial type situation like what you guys are talking about, how well you'll be able to calibrate these things down to what they've actually got to be able to do. You see what I mean?
I can answer some of that. On my 4 to 20 milliamp board, for example, I physically separate all the channels from each other, and I optically isolate all the channels from the microprocessor behind them. So they're all galvanically, I'm not sure how you pronounce that word, isolated from each other. There's really no need for decoupling capacitors because they're not even connected to each other in any way.
They come in independently. Okay, that was the other question I had. If you had a lot of inputs connected that were like, say, temperature sensors, thermocouples, something like that, the board's ability to supply steady power. Because I'm thinking they're going to want to calibrate this down to 1,000th of a volt type thing to make sure that, say, a temperature or something's dead on, that there's no fluctuation with the power from that board.
In most designs, you should be pretty hardened to power fluctuations, unless it's like super major, like if it goes from 5 volts to 3 volts. That's a no-no. So in most designs, there's a lot of regulation that takes place to keep the power steady. And in many cases, there's a lot of what I'm going to call low-pass bypassing afterwards to keep the noise from the power supply low, so that power supply noise does not get into your signal path. Does that make sense? I'm talking.
Yeah, I know what you mean.
Okay, I'm talking like an electrical engineer now, so I'm using that vocabulary. So yeah, that is something I try to pay attention to. That was particularly a problem with the 24-bit ADD converter board I designed. You had to be very, very, very aware of how much noise all your surrounding circuitry makes.
Right.
I'll also chime in here and say that I work in a lot of industrial facilities, from medical devices, pharmaceutical, to food and beverage, automotive. In many cases, you are not looking for anywhere near that kind of precision. As a matter of fact, most PLC cards are 13 or 14 bit. And if you can you're measuring pressure, you're measuring, temperature. If you're within a degree or two, in most cases, you're fine. You're measuring level. It's usually not that precision kind of thing. Now, Phil, for instance, is he does fast Fourier transforms with vibration and things like that, and he really is into that kind of resolution. So he may be able to speak more to that. But I would just say that in most industrial facilities, you're calibrating from a touch screen. You're not having NIST people necessarily coming in to calibrate your instruments. You're just comparing, you're taking a pressure reading or a temperature reading independently with a calibrated device, and then you're matching it up and you're making sure that it's linear. So as long as you keep noise away from it and things like that, like I said, a PLC card, an Allen Bradley PLC card, the normal ones are probably $1,000 to $1,200, and they're 13-bit.
Right.
And pretty repeatable. And even then, you still somebody goes out there and calibrates it once a month or something, or sets an alarm if something shifts too much. So it's just not a big deal in most plants. But
well, in some of the stuff I've worked with, it has been in pharma. We had one metrologist totally freak out on an engineer. He's like, well, it's close enough to 0 volts, isn't it? And he just looked at the guy and he goes, look, man, we're not building plastic swimming pools here. He's like, this is stuff that goes in people's eyes. It's got to be correct. So it was pretty funny.
Sure.
It was a pull-up resistor on our board, actually, that ended up causing the issue, but it had a dip switch. You can just turn it off and then it's fine.
Yeah.
But either way, it was worth it to see that guy go off on the engineer and him just looking like, I don't know what I should say now.
Exactly. All right. Well, I'm going to go back to a little screen share here and bring this back up. There we go. So hopefully we're back on here. We're getting towards the end. Let me see. I've got some links here. John, you mentioned sending me some links, but some of the ones you talked about, I think, hopefully are on here. So ESP32 is on here. And a lot of this stuff, you Google stuff and you'll find it. RaspberryPi.org has been helpful to me. I put Arduino on there just because I didn't have any other, just standard microcontrollers, non-computer things. Coon Bus, which is pretty industrial. Pi plates, of course. Jerry was nice enough to, I just sent him an invitation this morning, and he was nice enough to come on here and talk about his products. So far, I'm really impressed with those. It's just been really easy to put things together. Again, this one that I've got in my hand is going in my house. I'm not going to have any temperature issues. It's going to be 70, 68 degrees. If we get out of temperature, my wife's the one who's going to scream. It'll run all day long. And I'll be monitoring, I don't know, things like temperature and humidity and maybe some alarming stuff. And if it goes down, I'll be testing things like that card. I'll let it run 24 hours a day. And Jerry mentioned, yes, writing to an external device. There are also some utilities that I found online that will, it'll kind of minimize the writes to the card. It'll make use of your RAM and just use that. And then, make sure that if you are writing to the card that you kind of mean to write to the card, right? One guy that I'd love to get on here at some point, there's a guy named Brandon Ellis I go way back with. He owns a company called Elitech, and he has a very expensive data acquisition system called a Data Commander. And he seemed to be pretty negative on the Pi and things. And he said that all these Internet of Things applications are very intensive writing to the card. And so it destroys the cards. And I beg to differ on that. I think if you're in a plant, you can be doing a lot of things over Wi-Fi. You can be logging to the cloud, whatever you want to do, and you're not really making use of the card anyway to archive all that information. And then in cases like what Mike is talking about, where he's using a cell phone, cell modem, that is more of an issue. He's going to have to gather up his data, archive it one way or another, and then send it in bursts. He can't just be online all day. But in most plants, right? I think Jerry's addressed some of our concerns about how hardy things are. Here's people firing valves with it. People in I don't know what the first plant he mentioned was. It sounded like one of those nasty places, just like I'm in down in Miami. Yeah, I mean, and I think what's going to happen is you're going to see a lot more of this appearing in industrial applications. And there's going to be naysayers and people that are against using these devices. But again, I'll point to the price. I could buy probably 100 of these setups for what I could buy a single ControlLogix processor and some I/O for. And
Frank, we'd be happy to sell them to you.
What's that?
We'll be happy to sell them to you.
Yeah, well, and I think again at the edge, right, where you're just trying to pick up and acquire some data, and if it goes down, it's just not honestly that big of a deal. You lose a little bit of OEE information for an hour, and somebody goes out and they, maybe drop a whole new device in place and just plug it in. So I think we're going to see more and more of that. These industrial suppliers, the stuff's out of reach for a lot of people. I happen to have several ControlLogix PLCs and some Siemens and things like that, but my software licenses alone right now are costing me about $5,000 a year. That's insane. I'm a one-person company. And so for, integrators and things like that, people wanting to get started, you can't afford the Allen Bradley licenses and things like that. And then they're recurring payments. And I mean, I own all the software, and then they still hit me up for multiple licenses every year. So I kind of resent that, even though a big part of my life is teaching Allen Bradley and Siemens. I have to have the software. But I'm happy to see things going more this way, and I'm eager to try these applications anywhere I can, and really enjoying trying your stuff out, Jerry. Any other comments, questions?
Frank, it's Sean Terrell. I just wanted to throw a couple things out there. One is a link that I threw in the chat there for a GitHub project called IoT Stack. If you're using a Raspberry Pi, it's very, very helpful. It's basically a curses-based scripting menu that will allow you to install a whole stack of selection. You make your selections of different Docker hub or Docker containers. It installs all the software for you. One of the things that it has built in is the Pi to RAM script that basically stops you from writing any RAM and using that on your or using swap on your SD card. That's quite helpful. I don't know if you guys can see me. This is a device that I'm super bullish on, but it's the Beagle Pocket, the Beagle board Pocket. Yep. Beagle.
Yep.
And one of the things that's amazing is if you take a little bit of time and go on the TI website, the TI Satara AM335X processor was made for PLCs, for industrial processing systems. Octavo Systems has picked it up, and they've got a 400 ball package. That's the one that's on the Pocket Beagle. It's got 2 microcontrollers that are built in called PRUs. They run at 200 megahertz. Each one of them is individually controllable and has an entire industrial communication stack built on it. It'll do Modbus, it'll do CAN bus, it'll do KNX, it'll do some different encoder specifications. It'll even do some high speed processing stuff that are all built into the stack on those PRUs. So this is when you use a Beagle board, you actually get a real-time device. One of the other things with the Pocket Beagle, it's got 72 inputs and outputs on it. 5 of them are actual 0 to 5 volt analog, true analog, to the processor AIs. It's one of the few that you find that actually has AIs on it. It's a really, really, really neat package, and the Pocket Beagle is like $25. So the other thing about it is they made it actually compatible with the they call it the micro click line. So if you wanted to add, say, a power over Ethernet or even just an Ethernet connector, you can slap it on here. It'll just fit right on, and then you've got an Ethernet connector by using a basic third-party add-on. It's also got 4 gigabytes of eEMC, which is where you would install to. So you're not having to use that SD card space. You are using the eEMC, and then you can use the SD card spaces as add-on. I think it's a really cool device. I think it got a lot of uses. I'm excited to see what TI has coming out for the next generation of those processors. So the only other thing I wanted to say was when it comes to a lot of these projects, I find that the ESP8266 specifically if not the ESP32, does the job just as well as anything more expensive. And the reason why is because the ability to run an MQTT stack, you can actually run an MQTT broker on an ESP8266. You can run the whole network stack. You can have, a whole HTTP, website, everything with almost no effort on the front end of these things. And it is amazing how easy it is to actually get it up and running and do asynchronous data transfer with an 8266. Those have been around a little bit longer than the ESP32s, so they've got a little bit more community support to them. But the ESP32s are not far behind. So the ESP32s are getting a little bit easier to find these days. But the D1 Mini ESP8266 is a standardized kind of a platform with a standardized kind of a pinout that actually has like add-on modules and hats or whatever that you can put on. So it's just kind of food for thought, guys. If you buy a 10-pack of D1 Minis on Amazon, I promise you will find places to use them if you actually just get into some of the community resources and look at the projects that are out there. And now they've actually got it so that you can actually load projects straight from the browser. You don't even have to go into Platform IO or Arduino. You can just click from the browser and it'll load, like WLED is one of the great projects that you can do on the 8266 directly from the browser. It's phenomenal. So, and Jerry, to throw my opinion out, when it comes to PoE, I don't understand why it's not being done more. The only place I've really seen it is Opto22 has got their Rio that's running off of PoE. I would love to see a lot more PoE out in the industrial space. Anyway, that's just my take. Appreciate the info, guys. It's been great, listening to you guys. And Frank, it's a good webinar, man. I have to join you more in the future.
Sure. Well, thanks a lot. And again, I have different guests on. May have to have you on sometime. You seem to know quite a bit about that stuff. And Phil, of course, I think that's what he was using, is that D1 Mini or something, or an ESP device. So as far as power over Ethernet, yeah, I'm seeing it. Things like Cognex cameras and things like that are using it. It's definitely becoming more and more important. So, Jerry, quick question for you: are there any plans on building some of your same things for other devices like the ESP devices?
Once upon a time, I did verify that I could talk to the pipe plates with an Arduino, for example, and with the Spark. All you really need to do is know our protocol, and then you just need a SPI port. And if you have those things and maybe a few extra GPIO lines, you can port it to whatever you want if you're willing to invest time into porting the protocol and the language and all the commands with it. But I just did a very simple thing. No reason it couldn't be ported to the BeagleBone or the what did you call it? The mini Beagle, or that. I looked up the mini Beagle or whatever it was, and I saw a bunch of puppies. But yeah, there's no reason it couldn't be ported to that as well. It's just time and more. And I look at, the sheer volume of Raspberry Pis that have been sold as opposed to the sheer volume of Beagle boards. What, over 10 million Raspberry Pis have been sold? And it's kind of like, that's really the market.
Exactly.
So, for a given amount of time, you really got to put your time where it gets the most payoff. So that's why I've been focusing on the Raspberry Pi.
Yeah. People ask me all the time, why don't you teach Mitsubishi or Modicon or these other things? And it's exactly what you said. It's where the market is, right? And people aren't asking for it. And so that's where you tend to go. But yes.
I'm thinking about paying a visit to Automation Direct and saying, hey guys, you better get involved in this.
I didn't mention them, but I think they are in that space. I think their productivity pack may have some Raspberry Pi kind of supporting things. Don't know. I haven't checked, but yeah.
Okay. I haven't seen anything, but I'll go back and look. It's been a while.
Yeah. Okay. Well,
Frank, I got one suggestion. Maybe someday do a webinar comparing ladder networks to Node-RED, for example.
I can do that. I would need to know a lot more about Node-RED. I've done some of the kind of simple exercises, blink a light, push a button, that kind of thing. And then I did one of the ones that's on there that was on the Node-RED website that just said, go to this IP address. It's the USGS survey for earthquakes, and search for the latest earthquakes. And if the magnitude was over 7, type the word panic, right? And display it somewhere. And I did that, and it took me all of 5 or 10 minutes. It was amazing. So Node-RED does so much more than you could ever think about doing with a PLC. That's the problem. You couldn't do that in ladder. You just, even getting on the web, right? With ladder logic, doing those kind of things just takes so many other things, right? You'd be doing message instructions or Ethernet, messaging, and it just takes a lot more work. It's really for digital power. But to that note, since we're down toward the end, my next webinar, I don't have a specific date for or a specific topic, but it has been suggested that I kind of continue on this vein and we talk more about microcontrollers and things like Node-RED and maybe comparing, Node-RED to ladder, or there are actually 5 PLC languages. I write a lot of books, and all that's in my books and things on PLC programming. But there's actually 5 languages, one of which is structured text, and structured text is, people configure that in different ways depending on who the brand is, but it is like a high-level language. So it's along the lines of a Python or a C or a whatever. So you don't have to program in ladder logic, of course. It's just that most of your maintenance guys are trained in that. So the next webinar, it will be in about 2 weeks, and I usually put them on Fridays. I don't have a guest yet. I don't have a topic yet, but I think I probably will continue on this vein. At this point, we got like, 11 or 12 people here lurking around and watching this video. So it seems to be an important topic. I think a lot of people like discussing it. It's great to see some of the guys like Phil and Mike on here that are involved in this, and of course, members of my academy. And Jerry, it was great meeting you. Of course, I've ordered a bunch of your stuff and forgot to order the DIN plate, and then went ahead and ordered it last minute, and it didn't get here quite in time, but looking forward to getting that too. It's been great, guys. Any real quick last words before I sign off?
I've got one real quick thing. If y'all have 2 seconds, I was going to let you know about the power. My son has a Pi 4 that we got him for Christmas. And one of the things you could run on it was Minecraft. And I don't know if any of you guys have kids that play that, but it's really Java intensive and can actually slow a relatively powerful machine down considerably. And amazingly, that little Pi 4 could run Minecraft on a 1080 display, and it was completely smooth. And I was like, wow, that's actually pretty good. That's a lot more horsepower than you would think out of something like that, running Java.
Exactly. Yeah. Mine's been running in the other room, and I'm running several things. I did run into a pretty big problem with the cameras. The camera seems to have permanently destroyed some of my memory. Not on the RAM card. I look at everything and it's all there, but it stopped working to the point where I'm going to have to reformat the card.
One of the things I've heard is that high network IO, they don't do that well at it. They're okay, but they're not, because they only have one Ethernet port, one onboard NIC. And if you'd use it for 2, you're going to have a USB, and that's kind of sort of hodgepodge. It's not going to be as reliable as what I've heard. So,
yeah, I use the camera connector, and when I just do previews and use the VNC over to my computer, everything was fine. I can see it. But when I actually put it in a program and use the utilities for Pi Camera and started, calling things like display image or whatever, that seems to have grabbed some memory that I can't recover. So the only way I can think of is I'm gonna put another card on there and start over. But it's an $8 card.
That's the beauty of it.
That's right.
It's almost like having a VM. You just have a bunch of SD cards.
That's exactly right. Well, Mike will be learning something about that. He's about to put a bunch of stuff in, like he said, some tests and we'll see how long those RAM cards last, right? And I'm doing the same. I'm going to have it up for 24 hours a day, in a controlled environment. But it was great seeing everybody. I'm going to go ahead and sign off here, and I'll probably I do record this and put it on YouTube, and I may cut parts out or add parts at the end, but I'm going to go ahead and sign off here. It was great seeing everybody, and thank you for coming.
All righty. Thank
Thanks,
you.
Frank.
You guys
It's been
take
fun.
care.
The invite, Frank. Yeah, I just sort of started this business. I was working for a guy. I wasn't having a whole lot of fun, and the Raspberry Pi came out, and I looked at the Raspberry Pi, and I saw it's like I can run HDMI video on that thing, and and it's got I/O. I just kind of fell in love with it, and I had some ideas percolating where I wanted to stack boards up, and that's what happened back in 2014. So that's how pipe rates began.
Well, this sucker's pretty rugged. I mean, like I said, when you take apart a PLC, I don't care whose it is, you see the same stuff inside of it. And I don't care if it's an Allen Bradley $1,200 card. I just, their processors, I take the cover off of them, and it's a single board in there with the processor, and they're charging up to $18,000 for a processor. And then the software is a different story, right? And I just don't understand how they can get away with that, except that it's 70% of the installed base in the factories. It's been around forever.
I think you just answered your question. It's a de facto standard. So I'm going to be emphasizing Node-RED more and more as I work towards the industrial side. And for a couple of reasons, but Micro Day was one of those reasons.
Yeah.
So, and it only makes sense because I've always wanted to do a flow-based system, and I've been wanting to do it. I thought I'd build my own, but Node-RED's gotten to the point where it has stabilized. And there's a whole set of nodes for pipe plates now that a guy named Mike Harsh developed. So he did most of the legwork on that. So I would play with it, finally got around to playing with it myself. So I'm real pleased.
Yeah, it's been easy for me to learn, but there's so many functions and so many nodes out there that kind of, you have to go to different places to find them, and
Yeah.
Mike's a pro. He knows a lot about programming, so he can build functions for just about. He writes in a lot of Python and Java and whatever.
That's his background.
That's his background, and I'm a little more of a hardware and industrial guy, so that's kind of how we teamed up
Same
on this
here.
project. But yeah, I'm glad I met you, Jerry, and I'm looking forward to playing with a lot of your stuff. I've got it plugged together here, but haven't really wired it to anything yet.
Just use it for good and not evil, Frank.
Absolutely. There you go. And Phil, I need to get a hold of one of your garage door openers with that transmitter inside of it. My goodness.
Yeah, I mean, it's one of those things where we had kind of talked about the piggyback device.
Yeah.
And then that was going to be the low cost device. But really what kind of drove that decision is, I need to get the boron, I need to get the cellular device, because if I want to count boxes coming off a machine, I don't want to have to go to IT and ask to connect to the network. I just, if I'm a consultant and I'm approved to go in and do a basic calculation. And the other thing about it is yes, it's low cost. Yes, it's not super reliable, but what that is it's not intended to be a permanent device. It's intended to be more of a proof of concept to say, hey, the battery in this little sensor, it's only going to last a month or two anyways. We can count 10,000 boxes or 10,000 pallets coming out of your factory for the next month. We don't have to get any approval. We just stick this one little sensor eye. We'll count boxes coming off the line. It'll go to the cloud. Your own consultant's website or your own engineer's website rather than the company's website. And you can perform that calculation and say, hey, this is the value we can add. Now let's do it for real. Let's stick a real PLC on there. Let's invest $1,500 instead of $60. Because as I don't go to factories and do this type of stuff like Frank does, but spending some time with Frank, he said, well, I'd like to be able to count this box without, he's the PLC expert. So he can go into the existing PLC and get that number. Not all factories have PLC experts on staff, and they might just want to count boxes. And while that's trivial for Frank, that's somewhat difficult for, if you're managing a factory and have to hire an expert for $300-$400 an hour just to wire up a photo eye, you're starting to see, well, that's now going to be cost prohibitive. So that's really kind of the target focus.
The microprocessor you're talking about, I was in a conference call recently, and we were talking about using 32-bit ARM-based microprocessors, and somebody said, well, we're using this STM32. Well, what is it called? The ESPN32?
ESP.
Oh, okay. So yeah, this is the ESP32. It's just a little chip.
Yep.
It's got Wi-Fi, Bluetooth, low energy, all sorts of cool stuff on it.
Yep.
They've gotten really, really popular. You can put a little real-time operating system on it.
Yes.
Free RTOS goes on it. There's all sorts of, they're getting really popular. I haven't used this specific one in a project recently. And then the other company that I've really kind of liked watching is Particle boards. It's basically they've been having some pretty cool products come out. So I bit the bullet and purchased one of those. It was $60 around that amount for the board with the modem, but it does come with free connectivity with a variety of providers. And it all goes back to their centralized home dashboard.
So the point the guy was trying to make was he's moving more towards those as opposed to using, chips from companies like ST Micro and things like that. He says the learning curve on those things is a little steep. The documentation, there's a lot of Chinese and English mishmash, but those things are really powerful, and they're cheap. So that is a little bit more validation, if you will, for what you're doing.
Yeah, if you can get them. That's something I worry about with Mike. He's talking about needing thousands of Raspberry Pi 4s, and I don't know where he's going to get those short term, right?
No, and I told Mike that you better invest, find a compute module that works for you. Because he told me that too, and he said, I'll buy Raspberry Pis from you too, and I said, I don't sell those.
Yeah, I noticed you stopped doing that. It was listed at one point on your site. I got the price from there, but I think, yeah, they're harder to get now. And
I was going to Micro Center and I would just pick up a few and then I'd stock them just to have, one-stop shopping. But it was getting harder and harder. And Micro Center was saying one at a time. And just like, not worth it. Not worth it. And my price margins on those were nothing. So it's really no point in doing it. So that's where we are on those.
Well, hopefully you can get computes. Can you get a compute to stack into your board somehow? How would you?
Well, if I could get, in theory, yes. The compute module is just a board. It's just a little plugs into a socket. But what you need to do is bring out all the pins from the compute module to create what is essentially the Raspberry Pi now. So anything you do with the compute module is probably going to cost more than just a pure Raspberry Pi, but at least you have the guarantee of being able to have a Raspberry Pi compatible single board computer, if you can do it, because the Raspberry Pi Foundation, and now it's raspberrypi.com for the hardware, they are saying that they're going to make sure that compute modules are available to everybody. I'm not sure if they have held up to that promise, but that's their claim.
Yeah, raspberrypi.org was the one I had, but yeah, they and the compute, again, being able to get to the header for the GPIO, if you could get to that, then there's probably a way to get into your plates. So
yeah, I would have to somebody would have to come up with a breakout board, as they're called, that has the same form factor as a Raspberry Pi, but uses the compute module.
Yeah. Well, guys, I'm going to head out. I'm go home for lunch. I told my wife I'd be a little late, but this was a good webinar. Got lots of good participation and good seeing you guys. Good meeting you, Jerry and Phil. I've met you many times now.
Hey, good to meet.
All right, guys.
All right.
Thanks for the invite, Phil. Nice to meet you, Phil. Thanks for the invite, Frank.
All right.